Okay, so for 1, 2, and 3, you're going to be doing a little bit of IXL on this, and so I want to make sure that you know how to do this. For 1, 2, and 3, it asks you to tell whether the polygons were similar first, and then they wanted us to state the scale factor, okay? So to figure out whether the polygons are similar, we are going to need to compare the ratio of the sides, okay? If the ratio of the sides are the same, then they're similar, and if they're similar, that ratio is your scale factor. So we're kind of doing both of them at the same time. So someone tell me what side corresponds with AB? So I would compare 12 to 9. What would that reduce to? 4 over 3. Very good. Now I need to compare the other two corresponding sides and see if it matches. So what does this side, AD, correspond with? LP. So we're going to put 8 over 6, which would reduce to 4/3. Okay, so do these match? Yes. So since they match, that means yes, they're similar. And what would the scale factor be? Yes, and then our scale factor is 4 over 3. See how simple that is? Okay, let's try number 2 as well. So in number 2, we're comparing triangle DOG to triangle CAT. So what side does DO go with? CA. So I'm going to put 5 over 2. Does that reduce? No. Okay, and then I'm going to look at the other side, which is DG, and it is corresponding to? It's corresponding to CT, which is not there. Okay, so can we conclude that that one is similar? Why do we say no? What do you think, Emmy? Okay, so we don't actually have to find OG and we don't actually have to find CT. If they only give us one side, then all we're going to do is find the scale factor of the triangles using only that one side that we have. So the scale factor would be 5 over 2. I'm not sure we could technically determine that they are necessarily similar because we don't have enough information, but we would just find our scale factor. Okay, and then let's do number 3 as well. So number 3, it asks us to compare ABCD to DEF. Now, which triangle is ABCD? My left or my right one? My right. So I'm starting with my right and going to my left this time. So we have that BC corresponds with what side? EF. Okay, so that would be 30 over 15. What does that reduce to? 2 over 1, right? And then we have DF, which corresponds with AC. So we're going to put that as a ratio as well. So that would be 20 over 10, which is 2 over 1. So yes, this one's similar. and the scale factor is 2/1. You always want to write your scale factor as like a fraction, or sometimes you see it with the colon. You have to have a number. It would be, you couldn't just do 2 colon and then not do anything. So you always want to put it over 1. Okay, so let's look at our notes for today now. It is exactly what we did yesterday, but this time they're giving you angles and sides. So we're going to have to determine between whether we're looking at an angle or we're looking at a side. So reviewing from yesterday, what do we know about corresponding angles in similar polygons? They're congruent. Okay? What about corresponding sides in similar polygons? They're not similar. They're proportional. So that means that our angles, we're going to be setting those equal, the two corresponding equal, but the sides we set up as a what? A proportion. So that's going to be a fraction set equal to a fraction, and then we solve. Okay? So let's look at number 1. In number 1, they want me to find x. So is x referring to, I see x right here. Is this a side or an angle?
Side.
It's a side. So this one we're going to have to set up as a proportion, whereas my y's are what? Angles. And so those we set equal. So let's go ahead and do the angle because that's quicker. So we're going to do 3y equals 60 because those are my corresponding angles. I'm going to divide both sides by 3 and y equals 20. Okay, can somebody tell me why I didn't use angle 120? Okay, it doesn't correspond to 3y. It's not in the same spot. Very good. Okay, what side corresponds with x? 8. So I can do x over 8 equals, and then what side corresponds with 5? 12. So 5 over 12. So from there we learned that we just cross multiply. So I'm doing x times 12, which is 12x, equals 8 times 5, which is 40. We divide by 12, and x equals 10 over 3, right? 10 over 3. Okay, so this is exactly what we did yesterday, but now we're finding angles and sides at the same time. Yes? Because we're going to be finding the scale factor and similarity ratio a lot, which wants you to keep it in a fraction. So we're just going to keep everything in a fraction. So we're in a habit of that. Okay, let's look at number 2. So Lucero, looking at the x's in this figure, is the x going to be an angle or a side? Lucero? An angle. Okay, which means my y will be my side. Okay, so Luz, what two angles correspond together here? And 80. So how would you set that up to solve? Very good. 2x minus 4 equals 80 because angles are equal. So we are going to add 4 to both sides. That gives me 2x equals 84. Then to solve for x, we divide by 2, and x would equal 42. Very good. Okay, now, sides we can't just set equal. So, Bianca, what two sides correspond up there? 18 and y, okay. 15 and 6, okay. Raquel, how would you want to set those up to solve? Very good. Y over 18 equals 6 over 15. So remember, sometimes we have little figures and big figures. If you go little to big, the next time you do the fraction, it also has to be little to big. Keep the format the same. So from here, we cross multiply. We do y times 15, which gives me 15y. And then we do 6 times 18. Is that right? 108. Okay, and then from there we get y by itself, and we divide by 15. 36 over 5. I would like to see both, if you put a decimal. Okay, so those were pretty easy. They were very similar to the ones from yesterday. Now we're going to get into some that have some more x's in them. So let's look at number 3. No, let's skip 3. Let's look at let's move to 7. Okay, so for number 7, Alex, is my x going to be a side or an angle? It's going to be a side. Okay, which means my y is my angle. Okay, Lane, how would you set up your sides to solve there? X over 8 equals 5 over 10. Good. So x times 10 gives me 10x. And then 8 times 5 gives me 40. To solve for x, we divide by 10, and x equals 4. Okay. Now for the angle, how would we do the angle, Bevan? Very good. So we do y squared minus 10 equals 26. Okay, Ella Grace, what would you do from there to solve? Okay, add 10 to both sides. So we get y squared equals 36. What would we do from there?
Take the square root.
Very good. Take the square root. What do you need to make sure that you have in your answer? A plus or minus, and the square root of 36 is 6. Okay. Cal, in number 8, is x going to be a side or an angle? An angle. Okay, and what two angles are corresponding up here? Very good, 3x and 60, so that would be 3x equals 60. To get x by itself, we divide by 3, and x equals 20. Okay. Now for the sides, Margot, how would you set up the proportions of the sides? Very good. 8 over 18 equals y over y squared. Okay? So from here, we would cross multiply. So I'm doing 8 times y squared, which gives me 8y squared, equals, then I'm going to do 18 times y, which is 18y. So from here, what would we do? Very good. We want to subtract 18y first and move it over. Yes?
Why wouldn't we start with 18 over 8 because we started with 3x? Like, aren't we supposed to keep those the same?
Not the angles and the sides. The angles, whichever one we do with the angles, it doesn't matter if we go from this figure to this figure because we're just saying they're equal. It's when you start the proportion that matters. So since we started with 8 and went to 18, then when we set it equal, we'd have to go y to y squared. But the angles and the sides don't have to be the same. But if you did it that way, Bevan, then you'll end up with the same answer. So you can keep solving it exactly the same. Okay, so from here, we subtracted 18, so we got everything on one side, which was 8y squared minus 18y equals 0. So you should be able to move yours and get that same thing that I have, Bevan. Does that make sense? Okay, so from here, what type of factoring is this? GCF. What is a GCF? 2y. So that's going to leave me with 4y minus 9 equals 0. So what is the y outside always equal to? 0. And what would this y inside be equal to? 9/4. Perfect. All right, so how y'all feeling about this? Okay, we're going to do a couple more. So in number 9, George, which one would be my angle, x or y?
The X.
Okay, so x is going to be my angle. And what two angles correspond there? 9x squared and 64. Very good. So we would do 9x squared equals 64. Now, does anybody have an idea of how we would solve from here? Okay, I would divide by 9 first. And that's going to leave me with x squared equals 64 over 9. And then from there, I would take the square root of both sides. I'm going to get a plus and a minus. I know the square root of 64 is 8. And the square root of 9 is 3. Very good. Okay. Rennie, how would you set up to solve for the sides? Y minus 2 over y minus 3. Okay. Equals y plus 6 over y plus 4. Very good. So we practiced this skill yesterday. Remember, I like you to write this out so we can really see it. So when I multiply y minus 2 times y plus 4, I'm going to write y minus 2 in parentheses times y plus 4. And then when I do the other, I'm going to do the same thing. So y minus 3 times y plus 6. Okay, so yesterday we distributed. So we're going to take this y and we're going to multiply it by everything in the second parentheses. So that's going to be y squared plus 4y. Then I'm going to do the same thing for this negative 2. I'm going to take negative 2 and multiply it. So negative 2 times y is negative 2y. And negative 2 times 4 is a negative 8. Now I have to do that exact same thing in the second set of parentheses. So I'm going to do y times y, which is y squared, and y times 6, which is 6y. Then I'm also going to do negative 3 times y, which is negative 3y, and negative 3 times 6, which is negative 18. Now, that's a lot of terms, right? So let's go ahead and start combining our like terms, but also moving some terms. So let's go ahead and move my y squared to the other side. So I'm going to subtract y squared from both sides. So what does that give me here? It cancels out. What about over here? Okay, so they actually cancel out, which means we're not going to have to factor. All right? Then what about a positive 4y and a negative 2? That would give us a positive 2y minus 8 equals, what about a positive 6 and a negative 3? A positive 3y minus 18. Okay, so from there, what would y'all want to move? You want to move 8? So we're going to add 8 to both sides. That's going to give me 2y equals 3y minus 10. What would we move now? I would subtract 3y. That would give me a negative y equals a negative 10. Can I have a negative y? No. Nope. So I divide both by a negative 1, and y equals 10. Yes?
For, when you have y plus 6 over y plus 4, can you reduce it like to 2/3?
You cannot yet. If it was a single number without the y plus on both of them, you could reduce it to 3 over 2. But since it's connected by that addition property, you cannot reduce. Okay, so let's try one more, and then we'll see how y'all do. So for number 10, Cam, is y my angle or my side? My side. Okay. So how would you set up that proportion to solve for that side? Y plus 2 over y plus 2 equals what? Y minus 8 over 3. So Margot, this kind of goes with what you were talking about before. You were asking if we could reduce this 6 over 4 right here, and I said we couldn't. Sorry, Emmy. And we couldn't because of the addition. So now what do you see, Emmy?
I see that you can't do that when you have the cross.
Mm. Okay, so let's cross multiply and we'll explore the other option after. Okay, so we're going to take y plus 2 and we're going to multiply it by 3. So I'm going to write 3 times y plus 2. And then I'm also going to do y plus 2 times y minus 8. So this is going to be y plus 2 times y minus 8. I'm going to distribute out this 3, which is going to give me 3y plus 6 equals, and then I've got to distribute this y. So y times y is y squared. Y times negative 8 is negative 8y. Then I'm going to do the same thing with a positive 2, so 2 times y is 2y. And 2 times negative 8 is negative 16. Okay, so it looks like we're going to have to factor. Let's go ahead and start moving everything to one side. Do I want to move all 4 of these to the left or these 2 to the right? These 2 to the right. So what we're going to do is we are going to subtract 3y. So subtract 3y to get rid of it over here. It is not the same as y squared. I'm going to go ahead and bring down y squared. I have a negative 8, negative 3, positive 2. That's going to give me a negative 9y. And then I also have to subtract 6 and move that over so that it cancels out here. And what's a negative 16 and a negative 6? A negative 22. Okay, so from here we have 1, 2, 3 terms, so we're factoring by trinomial method. So go ahead and draw your parentheses in your y's. Do you have a question? Okay, so tell me what multiplies to give me a negative 22 and adds to give me a negative 9. Negative 11 and a positive 2. Does that work, y'all? Mm-hmm. So that means my y would actually be 11 and negative 2. Perfect. Now, had we reduced this to 1 because it's exactly the same, would we have gotten both these answers? No. If we reduce, we would only get one answer. So that's the problem with reducing, is if you reduced y plus 2 over y plus 2, because they're the same, which reduces to 1, it would not give us both our answers. Okay? So don't try to reduce before. All right, now let's find x. So for x, Lucero, what two angles are congruent there, or corresponding? X squared plus 4x and 60. So we would set those equal. That would give me x squared plus 4x equals 60. Very good. We need 60 on this side so we can factor, so we subtract 60 from both sides. That gives me x squared plus 4x minus 60 equals 0. This is also factoring by trinomial method, so go ahead and draw your parentheses. Put your x's. Now, I've got to find something that multiplies to give me negative 60, but adds to give me 4.
Negative 6 and 10. Yeah.
Okay, we need a positive 4, so we have to have a positive 10 and a negative 6. Okay? So that means that x would equal a negative 10 and a positive 6. Good. Okay, so I wanted to show you how to do the IXL because sometimes it can be kind of confusing. So looking at this first one on P1, we're writing the similarity statement. So this one has us start at E, go to F, and then to G. So E to F to G. Now, if you see, this is the same shape. So if we took this K part and we kind of flipped over this triangle so that it was going in the same direction like this, and then we had K up here, and we went in that same direction, it would be K to I to J. So that's what we're going to type in is K to I to J. Okay, now in this next one, we're going from C to D first. So C to D is this side right here. Now, see how this is given right here, and it's the short side. So we're looking at the short side that is also given here. Then it goes from D to E. So D to E is the long side that's not given. So we go to the long side that's not given. Then it goes from E to F, short side that's not given, short side that's not given. So that same order is the order that we're going in. So we went from C to E, C to D to E to F. So we would have to go from V to S to T to U. So V to S to T to U. So you're looking at corresponding sides and then going in that same order. Okay, we'll try one more like that and then we'll look at P3. So here, they go from F to G. So F to G is the short side that's given. So we're looking at the short side that's given. Then they go G to H. So G to H is the long side that's given. Our long side that's given is here. Then H to I, short side not given, short side not given. So we want to go in that same order again. So F to G to H to I would be P to Q to R to S. So P, Q, R, S. Okay, now let's look at P3 as well. Okay, so P3 has to do with identifying similar figures. Now, we talked about this in class. When you identify similar figures, you have to look for their similarity ratio, or, which is the same thing, the scale factor, which is basically a comparison of the sides. So I'm going to take the two sides and compare them. So 34 is my long side given. 34 is my long side given. So 34 over 34 is 1. And then we would take 25 and compare it to 28. Now, if I put 25 over 28, that does not equal 1. So these would not be similar. Okay, let's try another one of those. So here we have, well, we can clearly see this is a square and this is a rectangle. So if I compared 46 to 35, just to make sure, that's going to be 1 point something. And then 46 to 46 is going to be 1. Those are not the same, so this one also would not be similar. Okay, here's a good one. So let's look at this one. Now, I kind of want to take this figure right here and flip it over in my mind. So see how we have one mark here, and our one mark here's are on the bottom. If I flip it over so that it's kind of going like this, I know that's not a great drawing, but this would be WX, and this would be 45, 45, and 35. Then we compare the sides. So 28 goes with 35. So I would do 28 over 35, which reduces to 4 over 5. Then I'd look at the next side. So if you see the sides of our triangles here, they're the same. So I only have to do that once. I would do 45 to 36. And so 45 to 36 is going to be 5 over 4. So immediately we see that these do not actually match. It's actually the flip or the reverse of it. So these are not going to be similar either. Oh, except that I set up my ratio wrong. I went 28, this little figure, to this big figure in the first one. So I need to do the same in this one. So this should actually be flipped and be 36 over 45, which would give us the same ratio. Okay, now we have to test our last side. And so our last side would be 40 and 50. So remember, we went little to big, so we would have to do 40 over 50, and we know that reduces to 4 over 5. So this would actually be, yes, the two are similar. Okay, hope that helps out.